Hello all, so in this video we will solve a problem for simply supported beam carrying a couple. So the question is, a simply supported beam AB of length 6 meters is hinged at A and B. So basically we have a simply supported beam which is hinged on both sides. Let's say this is A and this is B, and he's saying that it is subjected to a clockwise couple. So it is basically a clockwise couple of intensity how much? 24 kilonewton meter at a distance of 2 meters from the left end. Okay, and what is the total span of this complete beam? It is 6 meters, so obviously this remaining distance would be 4. Okay, he is asking us to sketch the shear force diagram and bending moment diagram. So we will just simplify this like this, so for our easy understanding. So this is RA, this is RB, and we are having a clockwise moment of 24 kilonewton meter. Where it is acting, let me take it as C. So this distance is 2 meters and this distance is 4 meters. Okay, now we will start calculating the reactions first. So RA plus RB is equal to 0. Why I put 0? Because on this beam there is no forces acting. This is 24 kilonewton meter is a couple, it's a moment, it's not a force, so there are no downward forces. So RA plus RB 0. So from here I can write RA as minus RB. Okay, next we will take moments about point A, summation of moments about point A, and we will equate it to 0. So if I take moments about point A, RB is acting, RB will come towards A in negative direction, anti-clock direction. So it is minus RB into what is the span? 6. And I have a clockwise moment. Already the couple is clockwise, so just add plus 24 is equal to 0. So minus RB into 6 is equal to minus 24. So from here, what does RB turn out to be? RB will be equal to 24 by 6. So which means RB will be equal to 4 kilonewton. And once you get RB, what will be your RA value? It is minus RB. Therefore, RA is equal to minus 4 kilonewton. So people, here I will tell you one important point. If you want to put RA upward only, then you put it as minus 4. Otherwise, you can put RA as plus 4 and give it downward direction. Basically, RA is coming minus 4 means what? What we assume the upper direction is not correct. So actually, it means RA is acting downward. So you follow any one thing so that you will not get confused. So I will put RA upward direction only and I will put minus 4. What I got only I will substitute, and RB I will put plus 4. Okay. Now what is our next step? Shear force calculation. So our heading is shear force. So let's quickly do off the shear force calculation. So we will start with first shear force at A. What is shear force at A is equal to? Shear force at A will be equal to the reaction at A. So to calculate shear force at A, let me stand just beside A. Towards my left, I have RA which is acting upwards. So we know that left side upward is positive. So it should be plus RA, but RA value is minus 4. Therefore, it is minus 4 kilonewton. Next, we will calculate shear force at C. So at C, there is only couple acting. There is no shear force, there is no loading. So the minus 4 will go up to C in the same way. So it is minus 4. Means there are no loads, that's why the shear force will not get affected. Similarly, shear force at B also will be equal to minus 4 only, because again from C to B there is no loading. So minus 4 will go till there. Otherwise, when you're calculating shear force at B, you just stand at this point. So right side of my section RB, RUN, right side upward is negative, so it is again minus 4. So like this we will write the shear force. Next we will calculate the bending moment. So bending moment is a little different, you please see here. So bending moment at A will be 0, because I am standing on point A and I am calculating bending moment on point A. So RA into, there is no perpendicular distance, so RA into 0, so bending moment at A is 0. Now I will calculate bending moment just to left of C. Okay, I will calculate bending moment just to left of C. Means imagine that there is no influence of this 24 kilometer. Just say that I am standing at this point where there is no influence of the couple. So let's say I am standing at this point. Now what will be the moment at this bending moment at this point? RA is acting upward direction, so it will create a positive bending moment into 2. So it is plus RA into 2, because it's a positive bending moment, but RA value is -4. So minus 4 into 2 is minus 8 kilonewton meter. Now I will calculate bending moment just to right of C. Okay, because here in this I will take the influence of C. Now I am going towards right of C, means I am taking the influence of this couple also. So what will be the bending moment at C now? RA into 2, RA into 2, and you have 24, which will try to hog your beam. So it is a uh, bending moment which will try to push your beam upwards, which is a positive bending moment. So it is plus 24. So this will be minus 4 into 2 plus 24 minus 8 plus 24 will come out to be 16 kilonewton meter. If you want, you can also see here. Let's say we are at right of C now. So if you see towards right of your C, I calculated from left side. If you want, you can calculate from right side. Section at any, I mean, either towards right or left, you can calculate, right? So if you see towards the right side, RB is acting upward. It will try to create a positive bending moment. So RB value is 4 into perpendicular distance is 4. So 4 into 4, 16. So we got correct. Okay. And finally, bending moment at B. It will be 0 because when we are doing on B, there is no perpendicular distance. So now we will finish off our shear force and bending moment diagrams. So let me say from point C I'm dropping up I will draw. So first we will do the shear force diagram. So this is B, this is C, and this is A. You see shear force at A is -4, C -4, and B -4. So when you have a simply supported beam carrying a couple, the entire shear force diagram will be minus. So this is 4 kilonewton and this is also 4 kilonewton. Next comes, this is SFD. Next comes bending moment diagram. So when we are doing bending moment diagram, this is B, this is C, this is A. Bending moment at A is 0, bending moment at C is also 0. What is bending moment at C when we did towards left of C? -8. So draw -8 downward. Let us say this is 8 kNm. This is the BMD. And when we did towards the right of C, what was the bending moment? 16 plus. So let's say this is 16. So how would you join now? When you are moving from A to C, you got a negative bending moment. And when you are moving from C to B, you got a positive bending moment. So this is how you sketch the shear force and bending moment diagram for a simply supported beam carrying couple. So I hope all of you understood the video. Thanks for watching.